In the last video, I showed you an example to find when a value of x was closest to 4. And now, in the same way that x was never quite equal to 4, our two functions are never going to be quite exactly equal. And this is generally the case with working with any real data. So the approach that we're going to learn is pretty valuable. So just as when we tried to find when x is equal to 4, we can apply it to our functions by finding the difference between the two functions. And so the way we're going to do that is difference equals abs sine fun minus cosine fun. And so again, that's if you watched the last video, that is just going to subtract each value of the function from the other function, and that's if we're looking at intersections, we're going to want to look at points like just to the left of the intersection and just to the right, and that's why we use the absolute value. And then we also we're going to take the minimum difference to find when these intersections occur. So difference equals min difference. And I should point out that this isn't going to give us every intersection. There is a different way to do that, but that's not what I'm going to talk about in this video. So now, because of the way we set this problem up, we do have two intersections, and difference there I did, yeah, okay, should work now. So again, yeah, the way we set up this problem, we have two different intersection points. They just happen to be equal to the minimum difference. They're two values in this vector here that are equal, and so we could put those subscripts for where those two values occur into another vector called intersect subs. So using the find function again, we'll say find difference equal min 3 equals min difference. Hopefully I spelled that right. Okay, so yeah, so we can run this. Did not? Okay. Oh, it was over here. Okay, so now if I print out this to the screen, you can see that there are two places in this difference vector that a minimum value occurs, and that's at the 31st place and the 131st place. And so now, just to make things a little bit easier to read, let's extract these two values to two different variables. So we'll call sub1 this first value, this 31, so intersect subs 1, and sub2 equal intersect subs 2. And so we have our subscript now, but we also, what's really important to us is the x value at which that occurs. So we found, so this gives us the place in the vector that occurs, but we want to find the place on the x-axis that occurs. So for example, if I type in x of 31, we get 0.944, so that one. So we would expect that to be, so this is about this value, so that intersection would occur right here, and then probably our other one is right here. So let's determine what those x values are. So we can use that using the subscript. So x intersect 1 is x sub 1, and then the other intersection, x intersect 2, is x sub 2, and then we'll also want to find the y value that occurs, or I mean really just the values, not necessarily the y value, but the value of our function at that point. We could do that by either using the sine function or the cosine function. I'm going to go ahead and use the sine function, but I should just make a note that you could use both just because they are supposed to be equal there. So point 1 is sine fun sub 1, and then point 2 is sine fun sub 2. So I'm going to run this and spell things right. And okay, so now let's plot that and see what we get. So I'm going to use a method that I didn't cover up here, but I'll show you a different way. So plot figure 2, plot x sine fun. Let's make that red again, and then we'll have x cosine fun. Make that blue. And now we want to add to the graph our 2 points. So we'll have x intersect 1, point 1, and let's make them like black circles. So KO, and then we'll have x intersect 2 and point 2, and we'll have KO. Oh, and if you don't know how to do that thing I just did, where you have like point, not point cloud, point, you just hit the tab button. It's a nifty trick, but I actually don't use it that much. So let's also make the markers a little bit bigger. So if I run this now, you'll see that they're kind of small. I'm not doing well with the spelling. Intersect. Okay, there's an E here. Okay, should work. Nope. Point 1. Gotta do that. Okay, there we go. So we have our 2 intersection points, and let's make the marker size a little bit bigger. So marker size, let's make it 7. And so that's how we do it. We found the intersection points.